Warning: the following show features stunts performed either by professionals or under the supervision of professionals. Accordingly, Team Beeler and the producers must insist that no one attempt to recreate or reenact any stunt or activity performed on this show.
Created by
This is Jacob Beeler, and this is the Burnout. God. Now here's some general information on friction.
To get an insight into the fundamental role played by friction in the motion of a car, think about how a car behaves on a sheet of ice. For our purposes, we'll assume that there's no friction between the car and the ice. Firstly, suppose the car is stationary. A driver sitting in the car can put his foot on the accelerator and thus cause the engine to drive the wheels of the car. The result is that the driven wheels will spin on the ice, but the contact between the tires and the ice is smooth. No horizontal force will be generated. Work equals 0, because work equals force times displacement. That means your car ain't going nowhere.
now the physics behind the burnout.
Stupid Mario Ball!
Drive friction is the factor that enables the burnout, because it's directly proportional to the normal force between the two surfaces in contact. Normal force, in this case, is the weight of the car, 1,700 kilograms, times the force of gravity, 9.8 meters per second, squared, which comes to the sum of 16,660 newtons. You multiply your sum times 0.72, the coefficient of kinetic friction from a car on asphalt. Then it equals 11,995.2 newtons. Dry friction depends on the materials in contact. This factor is measured by the quantity known as the coefficient of friction, which is the ratio of the friction force to the normal force. And the quantity is unitless and should always be greater than 0, but less than 1 in most circumstances. It should also be noted that the coefficient of static friction increases the rougher the surface.
Dry friction is divided into two types. The first type of dry friction is static friction. This occurs when the two surfaces in contact are not in relative motion. That is, when one surface is stationary relative to the other surface, which is the car in motion, meaning no slipping of the tires. Another form of dry friction is kinetic friction. This occurs when two surfaces in contact are in relative motion, meaning when one surface is slipping or sliding across another surface, kinetic friction is always greater than the maximum static friction.
Here's some more examples of friction! Ah! Go.
Now friction also produces heat.
Oh, there we go. We got the campfire going, boys. Bye-bye.
Brought to you by Oven Mitt, Mario Ball, and Diet Coke.